Thank you. I had the privilege of attending the Wheaton College Philosophy Conference, at which 24 or so theistic arguments was first presented by Alvin Plantinga. I can personally testify it was a tour de force to listen to. The Kalam cosmological argument, so long neglected by philosophers, unfortunately did not appear in Plantinga's retinue. Indeed, the argument passes virtually unnoticed in the entire corpus of Plantinga's work. Neither supported nor refuted, the argument simply goes almost entirely unremarked. So I'm very grateful to Trent and the organizers of this conference for including the Kalam cosmological argument in the catch-all category of also-rans and so on. Well, what is the Kalam cosmological argument? Let's let the medieval Muslim theologian al-Ghazali speak for himself. He wrote, "Every being which begins has a cause for its beginning. Now, the world is a being which begins. Therefore, it possesses a cause for its beginning." Now, we shouldn't stumble at Ghazali's deductive formulation of the argument. Some philosophers seem to be under the misimpression that a good deductive argument must have premises which are known with certainty to be true. And since that's not the case for the Kalam argument, this is not a good argument. But I think that's clearly a mistake. The evidence for a good deductive argument needn't render its premises certain in order for that argument to be a good one. And the evidence for the two premises of the Kalam cosmological argument fares very well, I think, in comparison with the evidence in support of the premises of other theistic arguments. In particular, the scientific evidence in support of the premises of this argument is far in excess of the empirical support for almost any other theistic argument apart from the argument from fine-tuning. Moreover, if you do have misgivings about a deductive formulation, the argument can be easily reformulated inductively as an inference to the best explanation. We have good evidence that the universe began to exist. What is the best explanation of that fact? The comparative likelihoods of the evidence on theism versus the evidence on non-theism powerfully confirms theism. Now, I myself like to present the argument deductively because of the clarity and the simplicity of its premises. The two simple premises are the tip of an iceberg of interesting philosophical questions, but at least the tip of the iceberg is perspicuous. Now, I had expected to have something to say with regard to the first premise of the argument, but in the interests of time restrictions, let me say that I'm inclined to reformulate al-Ghazali's statement of the causal principle to the more modest principle. If the universe began to exist, then the universe has a cause of its beginning. And by so reformulating it, one will just clear the way of many unnecessary stumbling blocks in the mind of some. Now, what warrant might be offered in support of the causal premise? I have appealed to the metaphysical principle that something cannot come into being from nothing, which I take to be a sort of metaphysical first principle. I think that the most powerful objection to this claim would be the objection of Adolf Grünbaum that, so saying, assumes that the universe came into being at its beginning. Now, what Grünbaum has surfaced here is the very knotty debate between the tensed and tenseless theories of time. On a tenseless theory of time, even if the universe is past finite and had a beginning, the universe doesn't really come into being at its beginning point. Rather, the whole four-dimensional space-time manifold just exists tenselessly and has, so to speak, a front edge. But if a tensed theory of time is true, then the universe really did come into being at the moment of its inception, and that makes the premise that if it has a transcendent cause, I think, virtually inescapable. And so in order to fulfill my philosophical responsibilities in this respect, I wrote a trilogy of books on God, time, and eternity, two of which were devoted to the tenseless theory of time, a critical examination, and the tensed theory of time, a critical examination. And I argued for the tensed theory of time and against the tenseless theory of time, and therefore for the objectivity of temporal becoming, which would require that at its beginning the universe literally came into being. I might add appropriately, I think, that this trilogy was dedicated to Alvin Plantinga. The dedication to that trilogy reads as follows: to Alvin Plantinga, who by his life and his work has shown us the way. And what I was thinking of there was the way to do Christian philosophy. I have tried to follow Alvin Plantinga's advice to Christian philosophers to think integratively about philosophical problems from within the perspective of a Christian worldview. And I think Plantinga has modeled that beautifully for us. In a deeper sense, too, I'm saying that Plantinga has also pointed to him who said, "I am the way, the truth, and the life," namely Jesus Christ. And I've appreciated Al's life and work so much in his advancing the cause of the kingdom of God in Christian philosophy. Well, let's move on then to the second premise, which is the more interesting and controversial of the two, that the universe began to exist. I have defended 4 independent lines of evidence in support of the second premise, 2 philosophical and 2 scientific. Let's focus in the interest of time today on the philosophical arguments for the finitude of the past. The first argument might be called the argument from the impossibility of the existence of an actual infinite. And it can be formulated as follows: an actual infinite cannot exist. 2, an infinite temporal regress of events is an actual infinite. 3, therefore, an infinite temporal regress of events cannot exist. Now, this argument entails a commitment to what we might call finitism. That is to say, an Aristotelian view of the infinite as being merely potential and never actual. And the greatest challenge, I think, to such an Aristotelian view would issue from mathematical Platonism. Platonists believe that classical mathematics requires the existence of an actually infinite number of mathematical objects of various sorts. And it's been claimed that the same arguments against the existence of an actually infinite number of concrete objects would apply, mutatis mutandis, to abstract objects, with the result that classical mathematics would become impossible. But I think this allegation is far too hasty. It begs the question against anti-Platonist views of mathematical objects. The truth of classical mathematics and the ontology of mathematical objects are distinct questions, which are too often conflated by recent critics of the argument. In fact, today, most contemporary non-Platonists would not go to the intuitionistic extreme of denying mathematical legitimacy to the actual infinite. Rather, they would simply insist that the acceptance of the mathematical legitimacy of certain notions doesn't imply an ontological commitment to the reality of various objects. The abundance of nominalist, or as I prefer, anti-realist alternatives to Platonism, such as neutralism, free logic, constructibilism, modal structuralism, figuralism, noneism, pretense theory, and so on and so forth, renders the issue of the ontological status of mathematical entities at least a moot question. The realist, then, if he is to maintain that mathematical objects furnish a decisive counterexample to the denial of the existence of the actual infinite, must provide some overriding argument for the reality of the actual infinite, of mathematical objects, as well as provide rebutting, not merely undercutting, but rebutting defeaters of all the anti-realist alternatives which are consistent with classical mathematics, a task the prospects for success of which I think are dim. Now, it might be said that science demands that an actually infinite number of things exist. But this is, in fact, false. The notion of the potential infinite is entirely adequate to the needs of scientific theorizing. Solomon Pfefferman, who is a mathematician and logician at Stanford University, commenting that, quote, the actual infinite is not required for the mathematics of the physical world, goes on to explain, and I quote, infinitary concepts are not essential to the mathematization of science, all appearances to the contrary. And this puts into question the view that higher mathematics is somehow embodied in the world, rather than that it is the conceptual edifice raised by mankind in order to make sense of the world. Now, if mathematical Platonism does not provide, therefore, a decisive defeater for finitism, what warrant might there be for adopting a finitist perspective? Well, I think that the best way to support finitism is by means of various thought experiments, which illustrate the various absurdities that would result if an actual infinite were to be instantiated in the real world. Jose Bernadette, who is especially creative and effective at formulating such thought experiments, puts it well when he writes, viewed in abstracto, there is no logical contradiction involved in any of these enormities, but we have only to confront them in concreto for their outrageous absurdity to strike us full in the face. He has in mind especially what he calls paradoxes of the serrated continuum, such as the following, and this quoting from Bernadette's book, Infinity, an Essay in Metaphysics. He writes, here is a book lying on the table. Open it. Look at the first page. Measure its thickness. It is very thick indeed for a single sheet of paper, 1/2 inch thick. Now turn to the second page of the book. How thick is this second sheet of paper? 1/4 inch thick. And the third page of the book, how thick is this third sheet of paper? 1/8 inch thick ad infinitum. We are to posit not only that each page of the book is followed by an immediate successor, the thickness of which is 1/2 that of the immediately preceding page, but also, and this is not unimportant, that each page is separated from page 1 by a finite number of pages. These two conditions are logically compatible. There is no certifiable contradiction in their joint assertion, but they mutually entail that there is no last page in the book. Close the book. Turn it over so that the front cover of the book is now lying face down on the table. Now, slowly, lift the back cover of the book with the aim of exposing to view the stack of pages lying beneath it. There is nothing to see, for there is no last page in the book to meet our gaze, end quote. Bernadette imagines what would happen if we tried to touch the last page of the book. We cannot do it. Either there will be an impenetrable, invisible barrier at omega plus 1, which is the first state of affairs after the series of pages ordered by the ordinal type omega, which seems like science fiction, or else our fingers will penetrate through an infinity of pages without first penetrating a page, which recalls Zeno's paradoxes in spades, since in this case the pages are actual, not merely potential entities. What makes paradoxes like these especially powerful, as Bernadette points out, is that no process or super task is involved here. Each page is an actual entity having a finite thickness. None is a degenerate interval, which could be unbound from all of the others and the pages scattered to the four winds so that an actual infinity of pages would exist throughout space. If such a book cannot exist, therefore, neither can an actual infinite. Now, at this point, the actual infinitist has little choice, but in Graham Oppy's words, simply to embrace the conclusion of one's opponent's reductio ad absurdum argument. Oppy explains, these allegedly absurd situations are just what one ought to expect if there were physical infinities. Oppy's response, however, is unavailing. It does nothing to prove that the envisioned scenarios are not absurd, but only serves to reiterate, in effect, that if an actual infinite were to exist in reality, then the problem cases like Bernadette's book or Hilbert's hotel would result, which is not in dispute. The problem cases would not, after all, be problematic if the consequences would not result. Rather, the question is whether these consequences really are metaphysically absurd. And I think that's probably going to be a person-relative question, depending upon how much you're willing to swallow. Well, let's go to the second argument, which is the argument from the impossibility of the formation of an actual infinite by successive addition, which is independent of the first argument. This can be formulated as follows. A collection formed by successive addition cannot be an actual infinite. 2, the temporal series of events is a collection formed by successive addition. 3, therefore the temporal series of events cannot be an actual infinite. This version of the Kalam argument eventually became enshrined in the thesis of Immanuel Kant's first antinomy concerning time. And I was fascinated to find that Plantinga does address this question briefly in Warranted Christian Belief on page 25. Unfortunately, from my point of view at least, his verdict on Kant's argument is unfavorable, to put it mildly. He says that Kant's argument is hard to take seriously. Plantinga says it's not as if it is an argument the premises of which have a certain limited amount of intuitive plausibility. It is rather that this transition to the conclusion completely begs the question by assuming what was to be proved. So the argument really has no force at all. Well, talk about deflating. Does Kant's argument, however, really merit this disapprobation? Pay careful attention to Kant's actual statement of the argument. He wrote, if we assume that the world has no beginning in time, then up to every given moment an eternity has elapsed, and there has passed away in the world an infinite series of successive states of things. Now, the infinity of a series consists in the fact that it can never be completed through successive synthesis. It thus follows that it is impossible for an infinite world series to have passed away, and that a beginning of the world is therefore a necessary condition of the world's existence. Plantinga paraphrases the second sentence of Kant's argument as follows, quote, "According to the second premise, it is characteristic of an infinite series that it can't be completed by starting from the beginning and adding things, events say, one at a time." Plantinga first raises a cavil about this claim by appealing to the possibility of so-called supertasks. He writes, "According to the current lore about the infinite, however, there is no bar to completing the infinite series in a finite time if the time taken for each event diminishes appropriately." Now, I see no reason at all to believe what Plantinga calls the current lore about the infinite. The impossibility of the formation of an actual infinite by successive addition seems to me to be obvious in the case of beginning at some point and trying to reach infinity. For necessarily, given any finite number n plus 1 is always a finite number. Hence, the least transfinite cardinal number, Aleph null, has no immediate predecessor. It is not the terminus of the natural number series, but stands, as it were, outside the series and is the number of all the members in the series. This rules out the possibility of supertasks. The fatal flaw in all such scenarios, I think, is that the state of the system at omega plus 1 is causally unconnected to the successive states in the omega series of states. Since there is no last term in the series, the state of reality at omega plus 1 appears mysteriously from nowhere. The absurdity of such supertasks merely underlines the metaphysical impossibility of trying to convert a potential into an actual infinite by successive addition. Moreover, as Plantinga recognizes, this objection is really irrelevant because the series of past events was not formed in the manner of a supertask. The temporal series of events that the proponent of the Kalam argument is talking about comprises events having an arbitrary but constant, non-zero, finite duration. So, supertasks don't even come into the picture. Rather, Plantinga's real problem with Kant's argument is that it's question-begging. He writes, Kant points out that an infinite series can't be completed by starting from some point finitely far from the beginning and adding members finitely many at a time at a constant rate. The premise tells us that if you start from some finite point in the series, that is, some point finitely far from the beginning of the series, and add a finite number per unit time, then you will never complete the series. Fair enough. But if the world has existed for an infinite stretch of time, then there was no first moment, no first event, and no beginning, either to the series of moments or the series of events. More generally, at any preceding moment, an infinite time would already have elapsed. Plantinga claims that Kant's argument completely begs the question because it assumes what was to be proved, namely that the series in question has a beginning. Now, having read the standard refutations of Kant's argument, I've been tempted for many years to write an article entitled, "Was Kant a Dummkopf?" Are we seriously to believe that the Titan of Königsberg was so stupid that he argued for the beginning of the universe by assuming that the universe had a beginning? Nothing in Kant's argument says or implies that in an infinite series of past events, there was an infinitely distant beginning point. or the idea of a point finitely distant from the infinitely distant beginning point, as Plantinga alleges. An infinite series of past years prior to January 1, 2005, for example, is a series without a beginning that is completed on January 1. Such a series is of the ordinal type omega star, which is the ordinal type of the negative numbers. Now, we can argue about whether Kant was right that such a series cannot be completed by successive synthesis, or about the tensed theory of time that underlay this argument. But I don't think we should interpret him in such a way as to ascribe to him obvious blunders. For my part, it seems to me that although the problems will be different, the formation of an actually infinite collection, by never beginning and ending at a point, is scarcely less difficult than the formation of such a collection by beginning at a point and never ending. If one cannot count to infinity, how can one count down from infinity? If one cannot traverse the infinite by moving in one direction, how can you traverse it by turning around and moving in the opposite direction? I've been gratified in recent years by Alexander Proust's and Robert Kuhn's endorsement of Kalam arguments of this sort for the finitude of the past in their engaging discussion of the Grim Reaper paradox. We're to imagine that there are denumerably infinitely many Grim Reapers whom we may identify as gods in order to forestall any kinematic objections. You are alive at midnight. Grim Reaper number 1 will strike you dead at 1 a.m. if you are still alive then. Grim Reaper number 2 will strike you dead at 12:30 a.m. if you are still alive at that time. Grim Reaper number 3 will strike you dead at 12:15 a.m., and so on and on. Now, such a situation seems perfectly conceivable, given the possibility of an actually infinite number of things. But it leads to an impossibility. You cannot survive past midnight, and yet you cannot be killed by any Grim Reaper at any time. Graham Oppy responds to a similar paradox concerning infinitely many bells ringing with deafening peals by saying that there is no particular peal responsible for your deafness, but the collective effect of all the peals is to bring about deafness. Well, this response not only involves the most bizarre form of retrocausation, but is in any case inapplicable to the Grim Reaper version, because once you are dead, no further Grim Reaper will swing his scythe. And so collective action is just out of the question. Proust and Kuhn's show how to formulate the paradox so that the Grim Reapers are spread out over infinite time rather than over a single hour. For example, by having every Grim Reaper swing his scythe on January 1st of each past year, if you have managed to live that long. There are many other bizarre consequences of an infinite past formed by successive addition, and I would encourage other theistic philosophers to explore this question further. Now, Trent, am I out of time now?
You are a little bit over time.
All right, then I will simply, as I say, reserve the scientific discussion for another time, but encourage Christian philosophers to also begin to work in philosophy of cosmology, because this is a ripe and incredibly interesting and important area of philosophical inquiry as well.
Thanks, Bill. Now, for various reasons, I actually, Bill sent me a Word document to convert to a PowerPoint because I wasn't going to do handouts. Did nobody really get planting a doubt? Planting a doubt?
Oh!
Come on, people. And then there can't be an infinite past?
Oh.
Live a little, people, live a little. Philosophy doesn't have to be,
You're too clever for
man, all stuck in infinities and whatnot. Okay, this is going to be hard because there's a lot of people that want to ask questions. So just bear with me. Richard, you can start.
Thank you, Bill. If I could confine myself to your first philosophical argument, I think the objection applies to the second as well. We normally suppose that during the course of my first sentence I've uttered, an infinite number of events have occurred. The first last half a second, the next last a quarter of a second, and so on. And if that was indeed an infinite series of actual events, then of course you would be confronted with a reductio ad absurdum.
Yes.
So what you are saying is that it's not an actual series of events, it's only a potential series.
Right.
Now, how would you distinguish between a potential and an actual series? Because it seems to me that for each of those events, if, for example, there was a particle moving with a constant velocity during that time, for each of the moments picked out by those, at the beginning or end of those events, there would be a particular position occupied by that particle, which, if it hadn't occupied it at that time, then it would never have moved continuously. So how would you, it seems to me fairly obvious that they are actual events. And therefore, what does the claim that there cannot be an actual event, series of events amount to? Now, it seems to me that you are relying on the assumption that we can make a distinction between a universe which has an actual series of events preceding the present moment and one that doesn't.
Yes.
And it seems to me the only way we could do that is by talking of an actual series of events of the same finite length, that is to say an hour. That.
Yes.
Now that therefore makes a distinction between a universe which has an actual series of these going back and actually doesn't. But it seems to me it wouldn't distinguish between a universe which had a beginning and a universe that doesn't have a beginning, not for Grunbaum reason, but for a quite different reason. That is to say, suppose there is a universe which has a finite series of events back to a certain point. Now, one can only distinguish between a finite and an infinite series of events, or one can only talk of an event lasting a certain time if you have a system of clocks, potentially, which you can establish. And you can only have a system of clocks in a universe which is orderly and non-chaotic. Now, suppose there was a finite series of events back to a moment of time before which there was chaos, and before that there was nothing. Now, is this that universe would have had a beginning, although by the criterion of lasting, not in virtue of the criterion of lasting only a finite number of events, but in virtue of the criterion of nothing existing before that. And it seems to me that's the only way to distinguish between a beginning and a non-beginning universe, and you are implicitly appealing to the notion of finite length, which only applies to certain sorts of universes. So there's enough objectives.
It seems
Thank
to
you,
me,
Richard.
Richard, that there are two issues there that have been raised. Let me speak to each in turn. First, with respect to the difference between the potential and actual infinite, conceptually, we can distinguish between these by saying that the notion of a potential infinite is a limit concept. It is not a number. It is a limit which one endlessly approaches but never arrives at. So when I divide a finite distance in half and then in fourth and then in eighths, 16th, this is potentially infinite in the sense that infinity serves as a limit to that process, but I will never actually reach an infinity F division. By contrast, in an actual infinite, you have a collection which has a definite and determinate number of definite and discrete members. And these are such that a proper part of that collection has the same number of members of the same cardinality as the whole collection. And that serves to distinguish, at least conceptually, I think, the idea of actual from potential infinite. With regard to the specific example about the continuity of space and time, here I'm persuaded that regarding space and time as continuous is a result of the human mathematization of time and space. We have a model of continuous manifolds, which we then impose upon space and time to do our scientific work, and this kind of model works very well. But as you know, a good many quantum theorists think that ultimately reality isn't really to be described in that sort of continuous way. These are, as it were, useful fictions, and we shouldn't be misled into thinking that a line is actually composed of an infinite number of points. Rather, on an Aristotelian view, such as I would want to endorse, the line as a whole is logically prior to any parts, or points rather, that we would choose to denominate in it. It is not a composition of points. Rather, the line is logically prior to the points that we will pick out on it. And I think that's a coherent model of space and time that won't involve commitment to either continuous instants or points, or on the other hand, to discrete quanta of time and space. It would just say that these are the results of our mathematical imposition of modeling time and space. Now, the second question is one that I've dealt with in my trilogy. You are correct in saying that technically the Kalam cosmological argument doesn't really prove the beginning of time. What it proves is the beginning of metric time, that there cannot be an actually infinite number of arbitrary but equal non-zero finite intervals regressing into the past. And so the question arises, before clocks existed, before we had the expanding universe, did God literally exist before the universe in a non-metric time? And the Kalam argument is consistent with that hypothesis. If you are persuaded that, as you put it in one of your books, at the first moment of time, it was true that there were swans or there were not swans prior to this moment, that implies there was a prior moment at which God existed. And this argument's consistent with that. I myself would disagree with you and Lucas and Alan Padgett on your...
This is a test of the personnel alerting system.
You...
This is a test of the personnel alerting system. This is only a test.
All people leave the hotel.
Okay, now we'll just start all over and repeat all that.
Just with this sentence, that I give arguments against the metric conventionalism that I think you and Lucas and Padgett presuppose for your view. So while your view is, I think, a legitimate and compatible option with what I've shared, in the end, I opt for God being simply timeless, sans the universe.
Okay, go ahead, Liz.
So one thing someone might think counts against this argument is that it relies on a couple philosophically controversial things like anti-realism, being a Platonist anti-realist, that kind of thing. So I was wondering if there was a way you could narrow the scope of your claim about infinity, and rather than saying no actual infinite exists, say no actual infinite in the past exists or something, because it seems like the second one is all you need for the argument to go through, and then you wouldn't have to give anti-Platonist arguments, and someone could be a Platonist and be convinced by the argument.
Yeah.
So I was wondering what you thought about that.
I want these arguments to be as widely appealing as possible, and if someone can draw a principled distinction between concrete objects and abstract objects, such that you could have an actually infinite number of abstract objects, but you couldn't have an actually infinite number of concrete spatiotemporal objects, I'd be thrilled. I just haven't been able to see any sort of in principle distinction between those two. And in terms of the appeal of the argument, while I recognize that it's asking a lot, the burden of proof here, I think, is on the realist, because he's the one who's claiming he's got a bona fide counterexample of actually infinite things. And my more recent work on abstract objects over the last dozen years or so And that list that I read out of various anti-realist options that are on the table today make me think that this is so controverted an issue that to have an argument situated within the anti-realist camp is not that bad.
Okay. Brad, you'll be next, but I don't want to be geographically biased.
Thanks, Bill. A couple of things. One, the counterexamples seem selective, right, with the book, for example. So it doesn't seem like you can generate the same sorts of paradoxes if we just, for example, imagine a case where there's just infinitely many concrete objects. There's one here and one a bit farther and one a bit farther away, and space is infinite. Now, it might not in fact be infinite, but that seems like a coherent possible world. Alternatively, shouldn't there be a problem with, say, Lewis's view that there's infinitely many spatiotemporally unconnected possible, or shouldn't that give rise to some sort of incoherent, problem for you? It doesn't seem, it seems completely consistent.
Well, you're
to
right
assume
that
right?
the premise becomes all the more compelling by telling these stories that illustrate vividly the sort of situations you can get into, like a Hilbert's Hotel or so forth.
Yeah.
But I think, frankly, Chris, that for me, just any infinite collection, like an infinite library of black books and red books, every other one, and to say that there are just as many black books as there are in the collection of black books plus red books, to me is crazy. I mean, even at the most basic level, it just seems to me bizarre to think that a collection
You're just confusing
contains
subsets with proper subset with size, then, aren't you?
No, we're saying that these two things have the same cardinality.
Right.
And that seems to me to be bizarre, since the one includes all of the collection of the other, plus an infinite number more.
Then you have trouble with Cantor's notion of same size, then, right?
Well, I've been in two minds about that. This is a so-called Hume's principle, right? That two collections are equinumerous if they can put into a one-to-one correspondence
Right,
with
it's
each other.
not
And I think
Hume's
that the
principle, but-
proponent of the Kalam argument has two options here. He could either deny the principle by saying that this is merely a convention that is adopted by...
This is a test of the personnel alerting system. This is only a test.
Okay. Once is enough.
I'm going to say it again.
This is a test of the personnel alerting system. This is only a test.
That was half as long as the previous one.
At least it'll be over quick. So what were we? Oh yes, I was saying you could either deny the Hume's principle,
Yeah. I mean, that's just the
because
definition of
there's
same
no
size.
proof of it, Chris. It's a principle that works great for finite collections, but to assume it works for infinite collections is just an assumption. Or you could say
we
no.
got an entire theory.
Yeah.
that-
Well, and I don't
I mean,
deny
not
the
out of here,
consistency.
it's a very fruitful
Again,
assumption, I guess.
Test of the emergency broadcasting system. This is only a test.
Yeah, I'm not saying anything to attack classical mathematics. I'm not an intuitionist or endorsing intuitionism. I'm just trying to divorce the truth of classical mathematics from ontological commitments. And this will get into deeper issues of how we make ontological commitments, because I don't think we do it through first-order quantifiers and singular terms. Like neo-Quinians do. So that raises, and again, another one of these huge issues that's beneath the surface on.
Let me just mention, there's a paper by Paolo Mancosu about this issue of the definition of size and cardinality that I think would
Okay.
would
Give me the
play
reference
into. Yeah,
afterwards.
I'll give you that reference.
So in the interest of time, I'm going to be geographically biased and give it to Alex, and then Brad will have the last question.
Okay, so two things that are related. The first is you give this long list of non-realist theories of math. They don't all work with finitism. So, for instance, it seems to me that the most promising ones are something like mathematics is about what follows from axioms. Now, if what follows from the axioms is that there are infinitely many things, and it's impossible that there are infinitely many things, it follows that the axioms are inconsistent, and everything follows from inconsistent axioms. So you cannot take any non-realist theory that uses this kind of following from approach. That's going to include structuralism. It'll include, I think, promising versions of fictionalism. Right? I mean, there's something particularly problematic about a view on which mathematical statements not only aren't literally true of anything, but couldn't be true of anything. Now, one way of avoiding that would be if you could have an actual infinite that doesn't lead to at least many of the same problems. And you could do that if, for instance, you had an actual infinite that couldn't causally interact with anything. Right? So the Lewisian worlds don't causally interact with anything, or you could just have a bunch of causally inert objects. So it has seemed to some of us, thinking about Grim Reaper type stuff, the book that can be turned over and so on, that what's actually at issue is can an infinite number of things causally affect a single thing? Right. And then if you can say no to that, and you can still believe in actual infinites, and still have the Kalam argument.
Yeah, that would fulfill Liz's desideratum, wouldn't it, of drawing a principled distinction, and I appreciate that. That's worth exploring. I would, though, however, disagree with your initial remarks. I wasn't defending a sort of if-thenism, but, for example, pretense theory with regard to the axioms of set theory seems to me to be entirely tenable. The axioms are not to be taken as true, but to be imagined as true, and then you can draw the conclusions from that. But the whole thing is make-believe. And I find that to be a very plausible account of set theory.
Okay, you guys, hey, you guys talk about it later. Brad gets the last question.
Okay, great talk, Bill. I want to go back to space, back to what Richard was talking about. Let's grant that space is discrete, but still...
Space what?
Let's grant that space is discrete and not continuous. Okay. But still there's the question of what the overall size of a spatial dimension is. I take it that you would have to say that the spatial overall size is finite.
Yeah.
And then I wonder, do you think that space is curved on itself, like the surface of a sphere? Or do you think that there's a wall at the end? Or do you think there's something else?
But the notion of whether space is infinite or not depends upon the topology of space. You can have a Euclidean space that is finite. And here would be an example. You take the Euclidean plane and you roll it up like a tube, okay? Then you bend it around and connect the two ends so that you get a torus. That is a Euclidean space, but it's finite. And so you can do all kinds of topological things in order for space not to have an edge or a wall or something of that sort. And these are scientifically consistent with all the observational data.
So you would endorse one of those?
Yeah, something like that I would say is probably true.
Thanks.
Fortunately, our alerting system has been well tested. You can go home and say, Baylor has one of the best alerting systems, the most well-tested alerting systems in the business. That was a really great exchange. That's probably a very nearly a once-in-a-lifetime thing there. Thanks, Bill.
Thank you, Chair.